You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem. Good morning, good afternoon, and good evening, wherever you are. We're coming to you from Boston, Massachusetts. Today is September 11th, 2023. Hope everyone is doing well and staying safe. Bhavin, I see there's been a big change behind you. You're doing something. I feel like, is this because I've been giving you flack about it?
Not just you, dude. There are multiple people that give me flack about it.
For those who are listening and not viewing on YouTube, Bhavin's his background has always just been a white wall. So we were like, put something up, and there's some like scaffolding of wood behind him, which we were DIYing over the weekend or something.
Yeah, that's it. Like I think my wife eventually got fed up of this blank wall. She's like, yeah, we need to plan for something and do something. So she designed the whole thing, and then this weekend we spent like going to Home Depot a couple of times, getting the wood and cut it to the right size, and then just put it up. Had to borrow a nail gun, which I love a nail gun, dude. Like it makes things so much simpler. Like
a hammer and a nail.
Like the first thing that we'll put the liquid nails thing, like just glue it together and see how it works.
Sure.
And I don't believe in liquid nails anymore because the wood was just like, I don't want to stick to the wall. And then I got a nail gun and like bang, 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 done. Like,
well, awesome. I mean, the other thing is like wood's like imperfect, right? So it won't be like, and so is your wall, right? Your wall's probably different. It looks great. I mean, I'm excited to see the final product. It looks pretty cool. So
this is phase one. So like we'll get some caulking done, just choose a color, maybe paint the wall. I don't know how fast I'm going to work on this, but it's a work in progress.
It might be that way for a while. Okay, we'll see the evolution of
I know. Every other episode is like, oh, we have something new in the background.
A pretty nice little Saturday at Home Depot.
So actually, that was my weekend. Like, and this project and NFL being back, like, that's a perfect weekend.
Right? Yeah. Football.
The Patriots lost though, but I don't know. It still gives me some hope. Like the offense did look good. Defense was great, so I'm excited. Like Eagles are a good team. They went to the Super Bowl last year, so like losing to them by 5 points isn't that bad. At least this is week one. It was being 5
points in the end, right? Because they were kind of looking like
they were down 16-0. That was
like,
not fun.
Welcome back, Tom Brady. We're gonna make you the Team Hall of Fame, but we're gonna suck for you today. So
I know. No, I was glad that we scored some points before the halftime when they brought Tom Brady on stage, because that would have been really terrible. Like,
you're like, this is not how I envisioned it. Well, it was like raining too, so it's kind of a melancholy day for Tom Brady to show back up.
I think they made that announcement maybe last minute, like, no, this seems shitty right now, but we have a official ceremony planned next year in June, so come back for that. We want to sell you more tickets.
That's literally, and they will, because everyone knows Tom Brady. I'm not a Patriots fan, but I appreciate the sportsmanship coming.
I hope you're not a Giants fan, dude. They lost. I'm not.
No, I grew up a Redskins fan. Well,
nice.
The Commanders. But I never really followed them that closely. It was just like my father was a fan, so I became one. And now I just like watching football. So more of a baseball guy. So September, October, playoff baseball. That's where I'm in, even though I'm a Yankees fan, and they suck this year. So still love them though.
How was your weekend, Ryan?
It was good. I got outside mountain biking and did some other stuff. I saw you saw my Instagram. I was having some fun on one of my bikes for a training coming up. So I can't complain too much, other than the weather wasn't great. If you're in this area, you know what I'm talking about. And it was so humid. Like just being outside for an hour at any point, I just want to die and go inside. I don't know. It was like swimming when you're breathing.
Like I was watching NFL Red Zone, right? So watching multiple games at once. And then whenever they switched to the Patriots game, it was raining and it was humid. And then when they switched to like the LA Chargers and Dolphins game, it was like sunny and awesome. They would switch to a different game and it was sunny. I was like, man, shit.
Yeah. We didn't make out weather-wise on the East Coast. But yeah, can't complain. And
Mhm.
we got this episode first thing, on the Monday morning, which is a good way to start the day.
Yeah, let's do it.
Speaking of starting, we do have a great topic about Nodeless. We'll introduce our guest shortly, but we have a little bit of news, not too
Mhm.
much. Why don't you kick us off?
Yeah, sure. So, first thing, a new funding round, a pre-seed funding round from, I think, a Danish startup. They raised like 2 million euros to work on building or help developers build scalable backends and cloud infrastructures on Kubernetes faster. And that's about the
Cool.
extent of knowledge that I have. Like
Sure.
that's what
Sure.
I could find about them. I'm sure like this is pre-seed stage, right? That they're still figuring out what they are going after, but I'm just glad to see there's still movement in the community, in the Kubernetes ecosystem, and there are still these early stage startups trying to solve challenges, like issues with the overall Kubernetes experience. So
Absolutely.
I'm all in for it.
Yeah, me too.
And then next up, I think I have D2IQ. They announced a new version for their D2IQ Kubernetes platform, or DKP. The one thing that caught my eye was they built a chatbot because everybody has to do AI in some form. But it
Yeah,
just the reason I'm highlighting it is like it's not just generating kubectl commands, right? It's
sure.
the way they have trained the model on the back end is they, instead of going out and looking at the public repository, they have trained it on their internal knowledge base. So like everything that they have in their history, I'm sure, like from Mesosphere days, that's what the model is trained on. So it makes finding information, doing troubleshooting exercises really quickly if you are a D2IQ customer. So I don't know. That
I
sounds
love
like a
that
cool use
idea,
case.
honestly.
Yeah.
I really do. I think a lot of companies should do it, especially really large companies,
Yep.
because I mean, if you work at a huge company, there's so much sort of tribal knowledge that you have
Hmm.
to learn along the way. And it'd be great if you just had a chat bot, be like, what, where do I find this piece of information, this person, this project name, whatever it may be? Because
Yep.
otherwise, you wind up going down this rat hole of like spider web of like getting to the right information. I love that idea,
I
internal
know. And
knowledge
like
base. I mean,
if your product has a UI, it helps to build something like this inside the product itself, rather than, because if I'm a customer, right, like not everybody in my organization will have a customer account.
yeah,
I don't want to share passwords, and finding information that's behind a paywall might be tricky. So like having something in the product that's easy to find, easy to locate, I think that
absolutely.
definitely helps.
Cool, cool.
And then the final thing that I had was an open source utility by Fairwinds called Pluto. Initially, the name caught my eye, but then it actually solves for an interesting use case. As we all know, through the different Kubernetes releases, right, there are different APIs that get deprecated. Even not just in Kubernetes, even with Helm, there are some changes to the way the API works. This open source project or utility is command line based. It does a few things, like it checks your real time installation, so like runtime, looks at live Helm releases, it looks at your cluster resources that are running inside your Kubernetes cluster, and
Yep.
gives you a list of all the APIs that will be deprecated in the next release. And then
Oh,
it
nice.
also does a scan. It can also help you do a scan against your infrastructure as code repository. So if you have Terraform files that are deploying resources, it can scan that and let you know that, dude, this might break if you just go up one version. So this helps like people catch things earlier in the life cycle, rather than trying to troubleshoot why something isn't working that used to work before just after a Kubernetes update. So
Yeah.
that's why I think I just wanted to share this utility that I found.
Yeah, nice. I'm all for it. I also found something I wasn't familiar with, and I kind of really like that aspect of it because they're just like these companies or projects that just come out of nowhere.
Yeah.
The one I found was, I don't know if you've ever heard Rapid Fort.
Nope.
So neither have I, but they came out with an announcement and then sort of coined a term, which is why I kind of keyed in on this, called Software Attack Surface Management (SASM).
uh,
So they're security related. Just another acronym for us to learn,
I
or at
know.
least the article says that the startup is pioneering this term.
Okay.
But there's a lot happening in security, as we know. We always have, a ton of projects, a ton of new things going on, and it's a hugely growing space. Anyway, the whole idea behind this runtime protection is basically the company, as far as I understand it, do sort of the typical CI/CD pipeline stuff,
Hmm.
but also the active running software, right? So
Oh,
it
nice.
kind of hits both ends of it, giving
Yeah.
sort of a bigger sort of strategic sort of view into catching malware vulnerabilities or those kind of things. So anyway, I thought it was pretty interesting. I wanted to put a checkbox on the keep track of this new term, SASM. I mean, I'm going to
Right.
call it SASM. I don't know.
Yeah.
SAS.
Like wasm and sasm, and then we have some esperms and salsas.
Yeah, exactly. The other one was from InfluxDB, who we had on the show really early
Yep.
in
Last
the
year.
yeah, exactly. I forget which episode it is, but they came out with Influx DB clustered. So their whole InfluxDB 3.0 re-architecture,
Mm-hmm.
I think, started with their enterprise version, then like their hosted version, and so InfluxDB clustered is sort of their on-prem version.
Okay.
So if you wanted to run it in private cloud or hybrid cloud, this would be the version that you use, and it comes along with a lot of the benefits that they claim in 3.0, which is like 100 times faster queries and stuff like that. I know we were big fans of what they were up to even
Yeah.
last year. So the naming seemed a little weird because it was like I expected almost like because it was named clustered, it was this new cluster architecture or
Yeah. Yeah. Yeah.
something. But from what I understand and reading about it, it's sort of just their on-prem denotation. So
Okay. Nice. I'm just like still stuck at the 100x improvement that you just mentioned. 100x. Like, okay, that's great, but
on high cardinality data. So
oh,
not
okay. Like,
everything.
how slow was it before? Like that they can see 100x
Fair
improvement.
point. Yeah, they do claim a lot of stuff performance wise. They kind of talk about how 3.0 is really centered on performance as one of the big key
Gotcha.
takeaways. So I've used it briefly, but I know they're up to a lot of stuff there. I didn't put it in the news here, but I think they had some really great revenue growth too. But that's a different story.
I know.
That's the two main stories I had. There was a couple other links that we'll put in the show notes here from the blocks and files
Mhm.
folks, where they have a storage news ticker. So we do talk about storage, given our backgrounds, quite a lot. So if you're interested in those, there's some interesting things about what IOMesh is up to and some other stuff in the data protection and backup world. So go
Okay.
check those out if you must. That's it. Now we're ready to get into today's topic. So
I know. Let's talk some Nodeless.
yeah, some Nodeless. So we're going to talk about Nodeless today. If it's a term that's not familiar, I'm in the same boat. So we're going to learn all about it. We have Madhuri Yechuri, the founder and CEO of Elotl. They're up to a bunch of cool stuff. They have a couple things called Nova and Luna that we'll talk about, as well as just the whole Nodeless concept. So
Yeah.
let's get Madhuri on the show. Hi, Madhuri. It's so glad to have you on the Kubernetes Bytes show. Before we dive into all things Nodeless and what you're up to at Elotl, please introduce yourself and tell our audience a little bit about yourself.
Yeah, sure. Thanks, Ryan. Thanks, Bhavin, for having me on it. I have been in this ecosystem since 2015, I believe, when I worked with you, Ryan.
Yeah, Cluster HQ days.
Yes, good old Flocker. Just last week or 2 weeks ago, I was at this Kubernetes meetup in Amsterdam, and someone said, the best thing about Cluster HQ were your Flocker t-shirts.
Yeah, they were pretty awesome. We can thank Michael Franti, I think, for helping design those. He always picked the nicest material.
Yeah. Love all things containers and compute in particular, and have been very interested in this ecosystem since the beginning days when Kubernetes was, I think, just a glimmer in the eye of some product managers at Google.
Yeah.
And Nessus and Docker Swarm were the coolest toys on the block.
Yeah, I feel like if you were in this ecosystem anywhere starting like 2013 to 2015, you saw this quick transition to like what's the greatest thing right now, right? It was Meso, it was Docker and Docker Swarm. Everybody had Mesosphere. I worked at a company, and a lot of companies just got on that board, and then it was like, oh, Kubernetes is actually ready for production, so let's go that way.
I'm just glad you didn't include OpenStack in this list.
Yeah, well, I'm sure there's plenty of folks who have that experience as well.
Yeah, I skipped the OpenStack time frame completely. Like I went from VMware directly to Kubernetes, and I was like, yes, I
Yeah.
mean it.
I mean, those were great conferences, great technology, and I
Yeah.
know they pivoted. I didn't get involved. I didn't stay involved, I should say, after
Yeah.
they started like building Kubernetes on OpenStack. But it's all fun, I guess. At the end of the day.
Yeah, it's like one of our products currently is named Nova. And during one of
Mhm.
our
Oh
sales
yeah.
calls, my prospect said, "Hey, is it related to OpenStack Nova?" I was
Yeah.
like, "You're dating yourself."
Some PTSD for that prospect. Like, ooh.
That's too funny. I didn't even think of that when I was reviewing all this, but yeah, that's a good point.
Okay, so Madhuri, again, thanks for joining us. Right, I want to get started with like the most obvious question, and like that's something that I asked Ryan when he introduced this topic to me. I was like, "What is multi-cluster but nodeless Kubernetes platform? Like, what is that?"
Yeah, for sure. So fundamentally, the idea of Nodeless originated when back in 2015, we were thinking about transitioning from running monolithic apps on
Mhm.
on-prem data centers and virtual machines to running them inside containers, whether it
Mhm.
be Swarm or Mesosphere or Nomad or whatever, as microservices, where we had this whole idea of we need to start thinking about apps as not pets but cattle, where they're
Yep.
replaceable and they're modular. So the idea of Nodeless is when we have transitioned to cloud native deployments, where your compute itself is not something that you have to plan for with purchase orders and you have to upgrade at an yearly cadence. You can get
Mhm.
a compute of any shape, of any at any cost price point from any cloud provider at an
Yep.
API call and release it with an API call. So why are we still thinking about compute backing your infrastructure being as this hand managed pet, right? When you transition your application from pets to cattle. So the idea of Nodeless is just in time compute for your containerized application when the app comes up, and the compute goes away when the app goes away as well.
Okay, at least okay, that helps me, right? Because I was like, how can you run a cluster without nodes? So it's just that
Abstraction.
just in time, yeah, the just in time compute provisioning definitely like helps paint a clearer picture.
Yeah, I
Yeah,
like that.
go
I
ahead.
like that idea of, we as an industry got away from treating an individual server as a pet, but now this is more abstracted to like a pool of compute, right?
Yeah.
Where you treat that thing as not a pet too. Um, Now, I guess this is for my own benefit because I don't really know the answer to this, and that's perfect because you're here. I've heard nodeless be compared to serverless or just in time compared to serverless. So I've even seen articles that say, well, nodeless is just serverless. I'd love to hear your perspective on that.
Yeah. First of all, both Nodeless Domain, which includes us and a couple of other folks, as well
Hmm.
as serverless folks, we have been criticized as in we should not define your domain or the thought leadership with respect to what is missing. You should
Yeah.
actually, that's kind of a negative way of looking at it. So we are guilty of that. Um,
Okay.
so serverless, the idea of serverless is event driven, just in time applications, right?
Mm-hmm.
Which
Hmm.
could be
Sure.
containerized, which needn't be containerized. So
Yeah.
Yes.
it's just in time application that's coming up in response to the user driven traffic.
Mm.
The compute backing the application could be always on. So
Okay.
the whole idea of just in time everything would be serverless at the top and nodeless at the bottom.
Mm.
Your
Yeah.
pod comes up just in time in reaction to the increase in the web traffic or your Black Friday load or whatever,
Yeah.
and your pod is scheduled on a just in time provision compute using Nodeless.
Yeah.
So we in fact had a talk at Knative Con last year, I believe, where we did just in time all the way, where
Very cool.
just in time app was being provisioned on Knative
Yeah.
Yeah.
using serverless paradigms, and it was the pod was running on an EKS or any cluster Kubernetes cluster that was running in nodeless mode with just-in-time compute. So that
Okay.
is true just-in-time end-to-end, basically.
I like
But
that distinction too because we like Bob and I have had episodes about serverless on here, and it's just a terrible name for what it actually is, right? I think we've come to that conclusion, but it is
yep.
what the industry has picked for what it is. But yeah, the distinction of serverless is really more like application
Correct.
serverless or
Yeah.
something, and nodeless. I like that now. That
No.
clears it up for me quite a
Yeah.
bit.
No. again, I think that definitely helps, right? Like if you look at AWS Lambda, like your apps can come online, but AWS always has that underlying infrastructure running. So, okay, if I'm running Kubernetes clusters on my own, I still need to worry about the just-in-time provisioning of the infrastructure itself, and this is where Nodeless fits in. Okay.
Correct.
Uh,
Yeah, and actually, Knative project enables you to run your serverless functions on Kubernetes clusters.
yep.
So you already have that glue layer. So if you use serverless functions and Knative Kubernetes beneath it, and underneath that Nodeless, you have just-in-time stack all the way.
Okay, so the idea of just in time is awesome, right? I know even in the manufacturing thing, like Toyota did the just in time manufacturing processes. But what are some of the benefits or challenges, like of having this just in time or nodeless architecture? Like one of the things I can clearly see as a benefit is cost. Like I don't need to have a full fledged cluster running all the time. But then does that mean I have to wait for the spin up time every time my app wants to run? So can you share a bit more around that?
Yeah, for sure. So, cost is the thing that comes up right away because right now there is a huge market for post mortem cleanup of wasted spend of your cloud bills.
Yeah.
So, just in time actually prevents wasted spend. So, you don't have to track.
Sure.
But beyond cost, the biggest value proposition is actually DevOps time and energy in trying to keep track of hundreds of on demand shapes and spot shapes and your various other container as a service shapes like Fargate. And
Mhm.
cloud providers release better, cheaper instant shapes at pretty high cadence every 3 months or so. So the decision that the DevOps engineer made today might not be the optimal decision 3 months
Yeah.
later. So it's an ongoing like grunge work. And to answer your question about the spin up time, what we have noticed is the spin up time varies based on the compute shape that was picked,
Sure.
whether it's on
Yep.
demand, spot versus like CAS, like Fargate. And the depending on the app, the spin up time either matters or doesn't matter. So if you're running, for example, QA workloads, it
Yeah.
really doesn't matter if your QA
Right.
test starts now or 2 minutes later. That's the
Yep.
math. Right? And all your cloud providers guarantee eventual consistency for your spin up of your compute nodes. So it's
Mhm.
eventually going to come up. Of the hundreds of prospects we've talked to over the past 7 years, there's only been one prospect for whom it actually mattered, which was a chatbot application.
Gotcha.
So when someone types in a question, you
Response time.
expect the chatbot to
Yeah.
respond in like 3 milliseconds or whatever, right? So for that,
Okay.
in nodeless platforms, there is you can have pre-warmed instances. So you're keeping a couple of instances that are,
Okay.
even having a hard-coded number was sufficient to meet the SLAs.
Got
You
it.
don't have to over-engineer for startup time to begin with.
Okay. And like one last question, right? I'm still trying to wrap my head around this. Do I have like a minimal 3 node footprint when it comes to Kubernetes and then add more nodes? Or am I spinning up a new worker group when my application needs it?
Right. So Nodeless actually is smart enough to figure out whether your app needs to be bin packed or bin selected. Bin
Okay.
packing would mean the app resource footprint is so low that it doesn't make financial sense to spin up a separate compute node for it. It can actually be
Gotcha.
stuffed. That's bin packing. Bin selection would be for workloads like GPU, machine learning,
Right.
these kind of
Yep.
workloads, or your lift and shift of your giant JVM application that was running in a VM. You just push that within a
Lift and shift. Yeah.
container, and you're calling it a microservice or
Your
whatever.
20 gigabyte microservice.
So for those things, bin selection one to one is and Nodeless is smart enough to actually figure out whether your app should be bin packed or bin selected.
Yeah.
Got
Okay.
it. Got it.
Gotcha.
Yeah, I could imagine. I just think back to my Jenkins days of just like you have this sort of pet of pool of servers that seemingly everything goes wrong on when you're doing QA. And you're right. Like it probably only adds a matter of minutes, right, to like a full
Yeah.
pipeline run or something like that. I could imagine. Yeah, that's super nice. So yeah, it does then boil down to you have to think about what the application is, and then does it fit Nodeless, and
Mhm.
for I imagine a lot of the times you can figure out sort of like you said a hybrid model where if you do need those few around, you can keep them.
Yeah. It really shines in special case scenarios. Like, for example, if you have Mac iOS build and test, right?
Yeah.
You don't have Kubernetes running on Mac right now, but Nodeless will automatically detect that you need Mac compute shape for your iOS build, and it will spin up the Mac Metal instances on your cloud provider or your ARM shapes, right, or GPU shapes. So you don't have to special case, like have separate clusters or non-Kubernetes environment for your Mac iOS build and test team. So all of that goes out of the window, and it actually lets you consume Kubernetes as this standard black box interface, right?
Got it. Yeah, it's a good point to make. I mean, we're on a Kubernetes podcast, but it goes beyond that, right? You can obviously tailor sort of abstracted views of different types of compute, not just Kubernetes. Who knew? People do other things than Kubernetes. Well, let's talk a little bit about what you've been up to at Elotl and how you're sort of building solutions for this. You have a couple different product over there, Luna, Nova. Let's talk about Luna first. So what is Luna and how does it kind of help accomplish these goals?
Yeah, Luna is a just-in-time compute provisioner for any Kubernetes cluster on the major cloud providers. So it's currently used on AWS, GCP, Azure, and OCI, the major cloud providers. And it gives this standard out-of-the-box, just-in-time compute for any application running on your standard EKS cluster, GKE cluster, AKS cluster, and OKE cluster. And it can provision on-demand, Spot, Fargate, ARM, Mac, any compute shape needed based on the application's resource footprint. So it'll auto-detect what the app needs and provision the right compute shape for it. And it'll make the smart choice between bin selection versus bin packing as well.
Got it. So if someone were to use Luna, do they basically define what those different pools look like for them, and how does the application choose which pool?
That's the beauty of Luna, is you don't have to define anything.
Okay.
You drop Luna on your EKS cluster or your GKE cluster, and you continue shipping your applications through your GitOps pipeline or by hand or whatever CLI you use. On your compute cluster, and Luna will auto create the node pools if needed. The only thing you can do is you can blacklist certain node shapes if you don't want to use certain node shapes. For example, machine learning folks are really picky about, hey, I know that this algorithm is not performing well on this GPU shape, so I don't want you to pick this GPU shape.
Gotcha.
So you can say that Luna don't consider these shapes, but and you can also say consider these shapes from these instance families. So there's a lot of knobs available for you to select or unselect what compute shapes Luna should use. But if you don't tweak the knobs, Luna will consider all compute shapes available to you because it's running inside your cloud account on your Kubernetes cluster.
Okay, and as an end user, you choose which clouds you want to use, I imagine, or does Luna decide that? Okay.
So Luna is deployed on a cluster, so its worldview is a single cluster. Okay. So you drop Luna on EKS cluster, you drop Luna on GKE cluster 27, etc.
Okay. So Madhuri, I have worked with AWS Carpenter before and how it helps you select Spot instances so you can save cost. And I know Google Cloud also has a solution called Autopilot that kind of does similar things, right? So how does Luna compare to those cloud-based or cloud-specific solutions?
Yeah. Okay. First of all, we came to market first.
We're going to drop that pin right there. Congrats. Yeah.
And secondly, the cloud provider solutions have this, if I were working on Carpenter at AWS, I would make Carpenter first-class citizen for EKS clusters. We're actually working with a prospect where they went with Carpenter on EKS, and then they had to start using GCP in addition to in AWS, and Carpenter port for GCP wasn't available. So they're like, we are not interested in writing a Carpenter port for GCP. So then they switched to Luna because Luna is is exact same functionality on any cloud provider. So you don't have to, you're basically future proofing your
Yep.
multi-cloud strategy. And by multi-cloud, I don't mean stretched clusters, but if you want your footprint across various in siloed deployments across various cloud providers.
No, I think it definitely helps, right? Like it reduces the toil that platform teams have to go through when they want to switch between different clouds. And multi-cloud is a reality, like not just based on the discussions that we have been having with our previous guests, but even in the ecosystem, right? Whenever you're talking to people, like everybody's thinking about multi-cloud, if not already implementing it today. So no, that helps.
Yep. So they're great products for sure. And it's kind of validation for us that, hey, this is something that is needed in the market. Because I remember the first time I talked about Luna and Nodeless, it was at PromCon, I think 4 years ago. And people were like, the audience were like really frustrated. They're like, we have cluster autoscaler. Why would we need something like this? And it took like 3 or 4 years of people experiencing the pain points of hand managing your node pools that like, okay, you need to prevent wasted capacity, wasted spend.
Right. Otherwise, you have to kind of really apply a lot of different tools to accomplish anything similar. And that's just for that one cluster. Right?
Correct. Yeah.
Got it. So we've talked a lot about state. You have worked directly with Flocker in the past. And I think the question I have is, are the applications using Luna that are stateful, or how many of them are stateful, and how does that work? Does it basically just, consider the clusters nodeless and go on its merry way as provisioning volumes as it normally would? Or give me some more about that.
Yeah. So when Luna provisions just-in-time compute, the compute node is a first-class kubelet worker node. So your CSI will work, your CNI. So all of your ecosystem components work as is. It's just that the node wasn't provisioned 2 months ago waiting to run an application. It came up just in time. So your selection of your CSI driver and how your state works will be as expected.
Got it. So in that case, is it limited to the cloud providers, I guess, first-class CSI drivers where you can kind of put check mark and say, I want to use this? Or, can they also kind of look at other ecosystem tools as well and say, well, I really like this solution. Can you add this to my nodeless pool when it comes up?
Yeah, that's a really good question. So the template for the template AMI that is being used by Luna to provision just-in-time compute, there is a default template, but you can override parts of it. So some of our prospects, for example, they have their custom AMI that they baked in with their custom CSI, custom CNI. So you just say that, hey, Luna, use this AMI instead of the default EKS AMI. So and the cloud init will pull in the right, override the defaults that come in the default cloud init. So it comes with the default, which is the cloud provider default, but you can supply override.
Customize it. Okay. No, that makes sense.
So Luna provides that template. Sorry, guys. So one more thing. Luna provides that template, but they can basically extend it.
Right.
Okay, got it.
Okay. And when Ryan started talking about state, right, I was like, we have been talking about just-in-time provisioning and scaling up or scaling out. What about scale down? Like, how does Luna help me when my instances are going away? Does it, talking about state and stateful and stateless applications, right? How does it help me make it non-disruptive or make it persistent?
Yeah. So when your application is terminated either by the user or let's say it's your machine learning application and the job has completed, once the app is terminated, the underlying compute is automatically terminated by Luna after a certain grace period. The only exception is because Luna is aware of the pricing structure of the compute. Luna is smart about keeping the compute around for longer if needed. For example, Mac 1 Metal instances on AWS, the pricing structure is you're charged for 24 hours, even if you use it for 5 minutes and terminate it, you build for 24 hours. So Luna is aware of the pricing nitty-gritty details of the pricing structure. So it'll keep the node around for 24 hours in case another pod comes up. So it's smart in that sense that it's aware of the underlying cost characteristics and your workload characteristics. So it'll decide whether to terminate immediately or keep it around.
Okay. No, that makes sense. And like talking about the developer lifecycle, right? I know Ryan brought his Jenkins experience and like running QA pipelines. But today, like we talk a lot about GitOps frameworks and continuous delivery, and they have like a push model and a pull model. Like that's just applications being deployed. Does Luna integrate with tools like Argo CD or Flux and provision things, or it just like waits for the Kubernetes API server and to tell it like, okay, I have more workloads coming in, please scale out my cluster? How does
Yeah.
it work?
Yeah, it works at it's the second option that you presented. It works at a Kubernetes. It responds to the
Okay.
Kubernetes API servers, basically the scheduler bringing in a pod in pending state. It responds to that, so it doesn't have a need to integrate with anything that is not bound. So
Yeah.
whatever GitOps pipelines you have in your environment, they should work out of the box.
Okay. No,
Yeah.
that helps, right? Like I don't have to worry about individual integrations into different tools, and I can move between tools if I wanted to. So that's awesome. Thank you.
Correct. Yeah, sure, yeah.
Got it. Cool. So we probably could have had a separate podcast for both Luna and Nova, it sounds like. But I'm going to switch gears and talk about Nova a little bit. I guess the first thing is, what is Nova? How does it differ from Luna? And just generally, what is it?
Yeah. So when we started off with Nodeless, the big vision was to commoditize compute for Kubernetes across regions and across multiple cloud providers. So we wanted to solve the problem in two steps. The first step is solve it for a single cluster. Commoditize compute for a single cluster, and the second level is commoditize clusters for a fleet of clusters.
Yeah.
So if you have 2, 3, 5, or 1,600 clusters, you shouldn't be treating each cluster as a pet, because what's happening is when people are migrating to Kubernetes fleets, they are starting off with these fleet of homogeneous clusters with your Kubernetes API server version X and your CSI version Y and your CNI version Z, etc. But pretty soon, as soon as you hand over these clusters to individual business units, someone will install some security patch updates, and your clusters will diverge, and your clusters have become pets. So all of a sudden, you're not sure if you should terminate a cluster because there are no workloads running, or if it is like a special Snowflake cluster, right? So Nova basically creates this supercluster from a federation of your workload clusters, and it commoditizes clusters. So your supercluster is simply an API server, Kubernetes API server. So instead of all of your Kubernetes clients, whether it's GitOps clients or your kubectl clients talking to individual pet clusters, they talk to this single API server, and the DevOps person inserts policies as to where these apps should land. So these policies give you a lot of power and a rich language in expressing which underlying clusters are the right target clusters for the apps that are coming into the supercluster.
Got it. Talk a little bit more about those policies. Like what types of knobs and whistles are available?
Yeah, for sure. So an example would be availability-based scheduling policy. So if you're running a machine learning workload, right, and your machine learning workloads manifest says, I want NVIDIA GPU shape X. And let's say you have 10 clusters in region X on GCP and 20 clusters in region Y on GCP. And let's not even go to multi-cloud, right? Multi-region itself. And we are all familiar that not every GPU shape is available in every region on every cloud provider. So what's happening today is people are earmarking, hey, this cluster 27 in region Y has this GPU shape as Z available, and this other cluster in this other region has this other Snowflake GPU shape available. By the way, these GPU shape availabilities fluctuate. So it's not something that is set in stone, right? So when you have this Nova supercluster, Nova would create a single supercluster out of your 30 clusters, and your machine learning application is scheduled to Nova API server endpoint. And the policy is schedule my app to a cluster that has the available resources for running the application. So Nova knows that this cluster 27 in region Y has this GPU shape available for that the app needs, and it will automatically schedule the app to that cluster, if that makes sense.
Yeah, absolutely does. I couldn't tell you. I was working on sort of a problem where geospatial picture modeling and spinning up GPUs. I couldn't tell you how many times in Azure it'd be like, nope, not available, right? And you'd have to just keep trying, or like come on later that night and hope you get some, or keep them up and pay for them the whole
Yeah.
time. So I could see the value there. Now, does Nova and Luna work together, or are they distinct things?
Yeah, Nova and Luna are designed to work independently or together.
Okay.
So Luna is because Luna's value proposition is primarily on public cloud, right? Because it doesn't
Yeah.
matter whether you spin up just-in-time compute on on-prem. Whereas Nova, you can federate clusters on on-prem or public cloud. So Nova is simply shipping the workload to the right workload cluster that it selects, right?
Okay.
That workload cluster could be running Luna, it could be running cluster autoscaler, it could be running Carpenter, it could be running
Okay.
autopilot, it could be running nothing. So
Okay.
so it is like you can combine the two to have true just-in-time all the way. And by the way, Nova can terminate clusters as well. So it does what Luna does for a single cluster. If the cluster is not running any workloads, it will transition it to standby state and it will terminate the cluster. So you don't have this like graveyard of control planes flying around that you don't know what they were used for and why they need to be running all the time.
Yeah,
Okay.
I feel like we hear both stories where organizations either I hear them falling into two categories. One is they have a bunch of shared clusters and application pipelines go to those bigger shared clusters,
Yeah.
or each individual application or team gets their own cluster, right? And it sounds like Nova can actually be useful in both cases.
Right. Yeah. And it actually makes a lot more sense when you think about running your workflows through GitOps pipelines, because GitOps pipelines, you don't want to enumerate all of your pet clusters, 1600 pet
Yeah,
clusters in your Argo pipeline or your Flux
yeah,
pipeline.
that's fair.
So with Nova, you send your application through your GitOps pipeline to Nova API server endpoint.
Okay.
Nova
Got
will
it.
dispatch it, and it also enables you to maintain this homogeneous fleet, right? So you can perform things like cluster upgrades super easily.
Okay.
And you can maintain your LMA stack consistency, your logging, monitoring, analytics stack
Mm-hmm.
component. You can make sure that you can have consistent LMA stack versions on all of your red clusters. Red clusters get a red version, and blue
Yep.
clusters get blue version, because
Got it.
Nova
Okay.
will schedule policy will enable you to spread, schedule, replicate, things like that.
Okay. So, Madhuri, you said Nova can definitely help you delete clusters. So I'm assuming it can also like deploy new clusters as and when needed. If I need a different type of GPU shape, it for my deployment, it will create a new cluster in a specific region where it's available and
Right.
give me access to it, right?
Right. Yeah.
Okay.
Yeah. Yeah.
Okay. And then when Nova is managing these clusters or deploying these clusters, right? Does it spin up individual control planes? Like the reason I ask this is like Red Hat is working on an interesting thing called hosted control planes,
Hmm.
where the control plane nodes are actually running as pods on the master cluster or the supervisor cluster. So you're
Right.
not spending resources for all your worker nodes. Does Nova work with that, or Nova have a similar architecture?
So Nova deploys a Nova agent on your workload cluster control plane. So your
Okay.
workload cluster control plane could be a first class control plane like an EKS, or it could
Mhm.
be running as a virtual control plane in
Okay.
the scenario that you talked about. It doesn't matter.
Okay.
So Nova simply has this agent running on each workload cluster that it uses to schedule your
Got it.
workloads to.
Okay.
Gotcha. And
Yeah.
then you said Luna is cluster specific, right? Like it performs things inside the cluster. So it's
Right.
definitely not multi cloud on its own.
Right.
Is Nova multi cloud, right? Like, can I have a master cluster? Is master cluster the right term? That's my first question. But then if the master cluster is running in GCP or GKE, can it spin up these workload clusters in EKS as well?
Yes, yeah. That's the primary use case we are seeing is
Okay.
for Nova is multi-region fleets and multi-cloud fleets. Those are the
Okay. That's awesome.
and cloud bursting use case is also something that would be super valuable. So you can have your your primary cluster be on-prem, and if you want to burst to your cloud provider for excess capacity needs, you can do that, and it can bring back your footprint back to on-prem.
Okay, and I think that opens up another interesting use case in disaster recovery, right? Like if I don't want to pay for that pilot cluster or that secondary cluster all the time, I can just have Nova provision it on demand or just in time and have a DR site that's ready to go.
Yeah. HA and DR are actually really compelling use cases. When we built Nova out, our vision was when people would come to us and say that, hey, we have 5 clusters, we'd say that you're too small for a fleet manager. So you're better off managing your 5 clusters as pets. But then we started hearing about the HADR needs of stateful applications where you have a 3 active deployment or an active standby deployment, and failure detection and failure recovery things are needed for even 2 clusters, because Nova has this God's eye view of what's happening with your clusters as well as your applications, right?
Okay.
And it can spin up your DR site just in time, or it can spin up an HA site for if your region A goes down on cloud provider A, then it can spin up a region B cluster just in time and have your the second active run be deployed on that newly provisioned cluster.
Okay, that makes sense. I think the only thing I'm trying to think is how would data get copied over, but again, we can dive into it later.
Yeah. So our first version, so we are compute folks, and we want to work with the state folks and the networking folks in the ecosystem. So right now, Nova does whatever your underlying cloud provider, whatever knobs it gives you, right?
Okay.
Like if your cloud provider lets you share volumes between regions, then the volume is available, it'll recover. Or if your DB is doing in DB recovery, in DB replication, then the app is taking care of it. But looking forward, we want to work with the storage providers in the ecosystem and the networking providers in the ecosystem to build out the storage and networking model as well. Because, like I said, Nova has this God's eye view, so it knows when
when things go wrong.
So it can initiate the network and storage failovers, but we as a company are not interested in tackling these problems.
Gotcha.
Yeah, because then you open yourself up to a ton of just very specific use cases where you have to be aware of more about the application itself, where now it sounds like you can do the orchestration piece, and now it's up to whatever organization or team to make those movements, whether that's application to application data movement, stuff like that, right?
Right. And what we've seen with prospects so far is people have these very opinionated preferences for storage and networking solutions. So we don't want to impose things on them. We want to work with whatever they thought was the best choice for them, right?
Yeah.
Got it. Well, if we can talk about a few use cases. We don't have to name names, obviously, but I'd love to hear about some of the top use cases that come to mind, I guess, in terms of how people are using Nova.
Yeah, for sure. So the availability-based scheduling for machine learning workloads, that is a pretty compelling use case for machine learning workloads where you want to run a machine learning job that is either doing training or inference of machine learning workloads, and the shapes are bespoke on certain cloud providers. So because machine learning shapes are also expensive, you do not want them to be always on. So that's another reason why it's a really compelling use case. HA and DR of databases. So we are working with Percona and a couple of other folks, and we're going to be sharing a lot of the content at Data on Kubernetes Day at KubeCon. Actually.
Oh, nice. Okay.
Yeah. So that's a very compelling use case that even with 2 clusters or 3 clusters HADR, automating those workloads is a compelling use case. Cluster upgrades is another compelling use case where you want to perform a cluster upgrades. And if you guys remember this whole maintenance mode of virtual machines and ESX servers, right? You want to train your workloads because the clusters are commoditized. By changing the schedule policy, Nova will automatically reschedule your workload. You can say that I want my workload to run on blue cluster instead of red cluster. So your red clusters will be drained of all the workloads, and so you can perform upgrades. So fleet management is another compelling use case.
Got it. And I imagine there's a way where you could do that and have your application kind of running on both blue and red and
Correct. Yeah.
send
Yeah.
traffic to one another. Okay.
Yeah. That's another scheduling policy, which is spread scheduling. You can say that I want 80% of my deployments replicas to run on red clusters and 20% to run on blue clusters, and slowly transition over. And that's like one of the Argo talks we had at Rejects this year. Yeah, this summer was a demo of that, how you can slowly transition your traffic over.
If we'll have to grab any links or anything to those and
Yes.
include them in the show notes here, because I feel like I want to watch them too. Okay, I think that's all I had for that one. Bhavin, you had one more here.
Yeah. I just wanted to clarify things. I think we covered Luna is just cloud only, but Nova can work with on-prem deployments as well. Is that true? And then does it support all Kubernetes distributions?
Yes. Yeah. So Nova is you can deploy Nova agent on any workload cluster that Nova control plane can ingest as a workload cluster. Having said that, we have only tested it on EKS, GKE, AKS, OKE, and for on-prem we have tested it on MKE, Mirantis.
Nice.
So we do want, as opportunities and prospects come about. So technically it should work on other distros, but we can't claim that it's working on
of course.
it out. Yeah.
No, I think thank you for drawing that line, because we see vendors in the ecosystem we work with everything, but only when a customer actually tests it, it's we need to change or fix something. So
the crux
appreciate that.
Problems. Great. Well, I do want to give you a chance to talk about the community aspects of everything that you do. But before that, we are going to do our little Chat GPT section here. So I asked Chat GPT, what's the coolest things about nodeless computing? And so you can give me your answer, but I'll do a synopsis of what it also has here.
Okay, am I going first or ChatGPT?
Yeah, you can go first. Yeah.
The coolest thing about Nodeless is eliminate ongoing maintenance headache of compute management for Kubernetes across multiple cloud providers across regions, and prevent wasted spend.
Got it. Yeah, so when I asked this ChatGPT, it was interesting, and this is where I kind of started off in the beginning of this, where it says nodeless computing, also known as serverless computing. This is its first line. It's its first line. So I wanted to make sure we drew that distinction, and we did. So that's super helpful. It talks about how it's cool and innovative, and kind of lists out a whole bunch of different things that it associates with nodeless from wherever it's pulling its information. And it talks about auto scaling, nodeless computing being able to handle scaling of the resources. We definitely talked about that. It talks about co-efficiency, where nodeless computing, you could also pay for the actual resources and the processing time and those kind of things, which is, I think it's pulling from a lot of the serverless stuff a little bit there. It even talks about event driven. And so I think, information wise, definitely pulling some interesting things there. You can focus on code, not infrastructure. I actually like that one, right? Where developers can kind of concentrate. We talk about this in various aspects of the Kubernetes community, of the more abstractions we talk about getting, do you actually focus on the things that matter? High availability, fault tolerance, it talks about easy integration, right? I guess I would draw a line to that super cluster where, you have one thing to think about. Operational overhead, you also mentioned. So it's
this looks like the discussion that we just had, Ryan. This is just if we generate a transcript, this is it.
with a few other ones. Shorter time to market, which I think was an interesting point there. And community and ecosystem was its last one. It's saying it's a thriving developer community and a rich ecosystem of third-party tools and libraries. So I think that's a perfect segue. Thanks, ChatGPT, to talk about community a little bit more. Tell us about what you're doing in the community. You mentioned DOK, Data on Kubernetes Day, which is a day zero event at KubeCon, if folks didn't know. You talked about rejects, which is also that's before KubeCon as well, right? And so just give us some more about that.
Yeah, so we kicked off a multi-cluster meetup group in the EU version in Amsterdam was kicked off 2 weeks ago in
Great.
collaboration with a European cloud provider called Leaf Cloud.
Okay.
Multi-cluster is super interesting in the European market, especially because they don't have these top three vendors that are eating up the market. They
Mhm.
have a lot of small cloud providers that
Yeah.
are backed by their governments. So DR and HA become things that people need to plan for from day zero. So that was really interesting. We talked to a lot of people that were using Kubernetes as their de facto deployment platform and are thinking through their multi-region and multi-cloud strategies from day one. That was interesting. We are launching the multi-cluster meetup group US version on the 20th of this month. If you're in San Francisco Bay Area,
Sure.
please join the meetup group. And we have some cool talks. We have a principal engineer from Intuit who runs one of the oldest deployments and largest deployments of Kubernetes in production, talk
Nice.
about their
Very cool.
multi-cluster. And we have folks from Cloudera talking about data, actually building their platform for data on Kubernetes. And besides that, we have multi-cluster podcasts. So if you are a power user or practitioner, please let me
Yeah.
know and come on the podcast. And we used to do a lot of work in the virtual kubelet community, virtual
Mm-hmm.
kubelet ecosystem in the Luna space for a single cluster space. Virtual kubelet, unfortunately, the project couldn't take off really up to its potential because of Kubernetes conformance issues.
Yeah.
But that's a community that's really close to our heart because we've been involved in it for a long time. So I think it's still a CNCF project.
Got it. Makes sense. And will you be at KubeCon Chicago then?
Yes, of course. Yeah.
So seek Madhuri out. Come talk to us. Ask to be on her podcast, and yeah, we'll put all the links that were mentioned in this episode in the show notes. Any of the talks, we'll try to get anything that's available, like
Yeah.
Slack communities or whatever. We'll make that available. But I think that's going to end. I feel like we could talk another hour and a half, 2 hours about both of these things. It's a very interesting topic. I think very powerful topic. But I wanted to thank you for coming on the show today, Madhuri.
Yeah, it was really fun chatting with you, Ryan and Bhavin. Thanks so much for the insightful questions.
Yeah.
Yeah.
No
Thank you for
problem.
being an expert.
All right, Bob, and that was a fun conversation. I know the nodeless term is much more cleared up for me. Coming into it, I saw a ton of articles, like I said in the interview, about sort of how it is serverless, and I was always like, well, that can't be right. So
I know.
Madhuri's sort of a way of explaining it, how the application breakdown uses serverless, but when you want to just have the node side of things, the infrastructure side of things, it's nodeless, and you can kind of stack those on top of each other, which totally makes sense. I like that layered, at least in my brain, the layered viewpoint of it makes a lot more sense for me. What did you think?
I think my interpretation was like nodeless is basically just-in-time computing. Like you don't want to pay for resources that you're not using.
Sure.
This is a framework and an automation tool set with Luna, like that can help you provision compute nodes for your Kubernetes clusters as and when your applications needed it. So definitely helps save on cost. I really liked her point where she said Luna helps prevent wasted spend instead of like going back and like trying to fix things after the fact. So like prevention is better than cure. Like let me help you reduce costs right now instead of like so 6 months down the line when you already have spent like millions of dollars on AWS. Let's just start from like designing a good solution for their applications. I think I like that part a lot.
Yeah. The whole concept is really cool. I liked the term supercluster, or as you called it, master cluster, right?
Yeah, I got confused. Like I was like, did she say supercluster, master cluster? Like some higher level entity cluster.
Yeah. Super. I've heard supercluster in other, I think in OpenStack land, or maybe even in I forget where. But allowing sort of that consistency across a lot of clusters, right?
Yeah.
So I think treating a cluster itself as a commodity is something a lot of people probably aren't used to doing, even if they're giving out a ton of them. But I think, tying back to everything we hear about security these days, I think it just improves that whole sort of security posture when you have that sort of, I think Madhuri used the term God view, right?
Yeah.
Which can be really powerful in those scenarios to have those viewpoints. So really cool stuff, really fun stuff. I know
and I think
I will learn more about it.
Yeah, like the ability to provision clusters on demand is really cool. I know you brought up like people started by deploying like really huge clusters and doing in a multi-tenant way, but now slowly they're moving to like smaller clusters per individual developer or per application team. I think using a solution like Nova definitely helps customers adopt that mindset, right? Like you can have policies already defined, and then whenever a developer needs cluster for any task, they can just spin up a cluster. The super cluster spins it up with the right policies, the right security guardrails, and they can test everything out. It can delete cluster again just in time, like on demand cluster. So that definitely helps, I think. So a great episode.
Yeah, exactly. I think a lot of the detail and the fact that you can do sort of a hybrid model, right? If you're not like totally sold on it, because we talked a lot about the sort of warm up times in our serverless episodes. And I was like, well, that's got to be the same concern, but worse in this scenario. But yeah, it sounds like there's a way to run it either way. Yeah, agreed. I think we could have Madhuri back on the show and talk for a whole nother couple hours if we really wanted to about this kind of stuff. Reminder for anyone who wants to sync up with us or Madhuri, she will be at KubeCon. If you're going to be at KubeCon, go check that out, or the various meetups that we talked about. We will link them in the show notes if you are in one of those areas and are interested. Well,
I just have one more thing to share with our listeners, right? I know we have been doing this podcast for a while. We did start a YouTube channel, and most of our listenership still comes from the audio format. Yeah. But if you are a listener, go and hit subscribe and like on the YouTube channel, right? Like give us access to those YouTube algorithms where we suggest, or YouTube suggests the podcast to other Kubernetes users or Kubernetes and people that are interested in Kubernetes. That will help us out a lot. So just one action item or call to action from my end, Ryan, this time.
Absolutely. Come join our Slack channel. Give us some feedback or episode. Or if you're at KubeCon, come talk to us. If you have a topic that'd be great on the show, we'd love to talk to you. We're going to be doing hopefully a live thing like we did last year at Detroit, which was a lot of fun, and put out some episodes that are live. So cool. Well, I think that brings us to the end of today's episode. I'm Ryan.
I'm Bhavin.
Thanks for joining another episode of Kubernetes Bytes. Thank you for listening to the Kubernetes Bytes podcast.